Hey everyone, geophysicist Stefan Burns here with an important astro update for you on a sun-grazing comet that has flown into our solar system. This is C2026A1 MAPS. It was recently discovered back on January 13th, and it is part of the Kreutz sun-grazing comet family, meaning it will get very, very, very close to the sun during its perihelion, coming closer than the Earth-Moon separation distance. In fact, it may even impact the sun. If that does occur, we could be in for a significant space weather event, as we have seen prior cometary impacts to the sun triggering significant coronal mass ejections. And what makes this comet so special is not only is it a sun-grazing comet, it's also quite large. It is the furthest out ever detected Kreutz sungrazer at beyond 1 astronomical unit. And it also has a diameter estimated up to 2.4 kilometers, or about 1.5 miles, meaning that it's quite large. So it could perhaps survive that perihelion if it doesn't do the impact, meaning it could become a great comet with an extremely bright and long comet tail. That could occur after its closest approach on the 4th, though it will start to grow a tail before then. But this could go down as one of the greatest comets of all time. That certainly is a possibility, though we'll have to wait and see if that occurs, and we won't have more information on this until later in March. Really, the end of March is where we're really going to start having a better understanding as to what the most likely potentials are with this comet. And here we have that new data. We see a plot of our heliocentric distance here on the x-axis. This is logarithmic, by the way, so that would be 0.2 AU. This right there, for example, would be 0.9 AU. That's 1 astronomical unit, the distance from the Earth to the sun. And then our y-axis is our apparent magnitude, or in other words, the brightness of this object. And so for reference, Venus, the planet that's one closer in to the sun than we are, is the brightest object in the sky other than the sun and the moon. It has a maximum apparent magnitude of -4.4. You start with positive values, you go to negative values. So that's very, very bright. We see some other Kreutz sungrazers here. This is C2024 S1 Atlas. It never got that bright. It did get up to about 6, maybe even 5 or so. And then you kind of move up. We have Comet Lovejoy in 2011. It got a bit brighter than that, getting up to about 3. And then you have Ikea Seki Comet in 1965, becoming very, very bright. Clearly a great comet. And then we have the Great Comet of 1882 here, which was incredibly bright, going up to about -3 in its apparent magnitude. So this is kind of the scale range of prior comets, Kreutz sungrazers, and how they've performed in terms of their brightness as they've gone closer to the sun. Well, here we see MAPS right now. And the key thing to notice here is that none of these other comets have observations this far out, because again, this is the furthest out ever detected Kreutz sungrazer, which means that A, our observatories now are better than they ever have been, which is true, but B, also it's quite large. And with a possible maximum diameter, that's the current estimate, of up to 2.4 kilometers or 1.5 miles, that means that it's more likely to survive perihelion if it doesn't do that impact, meaning it's more likely to put on a big show. It just simply has more mass and more gravity to hold it together, even though it's passing so close to the sun. Our latest data from the middle of February showing the apparent magnitude of about 14. You see these 2 dashed lines there. We don't exactly have a definitive answer yet as to kind of its trajectory, where it's going to go. This latest data point indicating it's more likely to kind of go up here, but we could see it settle out. We've also see here with C2024 S1 Atlas, quite a bit of variability in that light curve before it kind of settled off here like that. But this latest data does indicate with a little bit more likelihood of it kind of going into this Ikea Seki range, and perhaps it becomes even a greater comet than that, similar to 1882 R1 here. That would mean that this is one of the bigger pieces that we've seen. Again, that estimate going up to 2.4 kilometers, but we could see that change as it gets closer to the inner solar system. We start to get better observations of it. We do have some imagery of this thanks to Gerald Raymond and Michael Yeager out of Namibia. This was taken on the 18th right here, and we see C2024 A1 MAPS right there. So it's still quite dim. You need a good observatory and telescope to see this. it has better viewing from the southern hemisphere because it's coming up south of the ecliptic plane. So if it gets really bright during that perihelion around the 3rd, 4th, and 5th of April, people in the northern hemisphere could see it close to dusk and also dawn right at that time period because, again, it's really close to the sun. But right now, viewing is good for people in the southern hemisphere and not for anyone in the northern hemisphere. So this is their latest photo here, and we can see the placement of that within the sky map. And so here we see the ecliptic plane, and it is slowly going up towards the sun. We can also look at our orbital viewer so we can really see how it's coming up from below, and I'll just hit play and you'll see it zoom in here. Again, notice how it starts to get really close in March, okay? And then it does that perihelion. Let's go back in time a little bit. But we will have a little bit of difficulty viewing it as it gets closer because it is going to be relatively close to the opposite side of the sun, near Venus. So it may hinder our ability to see a little bit. People are going to be looking through the glare of the sun to better characterize this comet. Of course, as it gets closer and closer to perihelion, that's going to get harder and harder. But we should still be able to get measurements. And then right here, we see it getting very close. This is the ecliptic plane like that. And then on the 4th of April is when it goes down. That is based off our latest measurements on this, specifically around 1400 universal time. It'll be swinging around and then continuing on its way again back down to the southern hemisphere. Though there should be some viewing from the northern hemisphere at that time. We will be close to the equinox, so there should be equal viewing in general, north and south, but southern hemisphere is still favored, and then it will zoom off on its way. So that's it, just a quick update for you today on this sun-grazing comet. I will have more for you on this as time goes on. We get new data and observations, especially if there are critical updates. So make sure you subscribe to the channel. Again, I've been your host, Stefan Burns. Thank you all so much for watching. Smash that thumbs up button to help the channel grow. Wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.